Okay, X2, one-dimensional motion. Explain who Rene Descartes is in the history of physics. Okay, let's see. Galileo Galilei first introduced the concept of the frame of reference. Yes, right. After that, Descartes introduced the rectangular coordinate system. Now it is called the Cartesian coordinate system. This Cartesian is the objective of Descartes. Like Newton, Descartes had no idea about energy. Sure, while we learn physics, we learn energy absolutely, but it took almost 100 years from Newton for people to understand the energy. The energy concept began with his competitor, Leibniz. But the establishment was about in the French Revolution or Industrial Revolution. So due to the introduction of the Cartesian coordinate system, the analysis Euclidean geometry became accessible algebraically. Yes, from elementary school, you introduced the number line. This was created by Descartes. And when you're in middle school, you draw XY plane, right? And then straight line y equals ax plus b, something like that. And many curves can be represented by the algebraic equation. It was created by Descartes. Descartes' introduction of Cartesian coordinate system made us to solve geometry problem very simply. But geometry is the space for physics problem. Okay? In physics, there are two spaces, spatial space and time. Consider a particle whose position at time t is something like that. This is a problem of working on the dimension, physical dimension. This one is a position, is not usual x that is given in mathematics textbook, not in mathematics textbook. X is just unknown, but x in physics is a kind of displacement. This one has the scale of length. You must distinguish this from mathematical x. Equals 8 times t to the nth power. Okay, we have equality. Two mathematical, physical objects must be of the same dimensions. Therefore, this constant a has some physical dimensions. How can I find that? A equals x of t divided by t to the nth power. If I consider the dimensions only, A must have these physical dimensions. What about this kind of position? This one is a kind of solution. For example, there's a friction and something is moving initially with some initial speed. Because of friction, it slows down. Finally, it stops at some point. The position can be expressed as this kind of exponential form. Let's see. We know what E is. E is n goes to infinity, 1 plus 1 over n to the nth power. That is Euler number, Bernoulli's definition of Euler number. What about x? Okay, and actually this is this kind of form. And why don't we redefine nx by n prime? Then this one becomes nx. Wait second. This should be 1. This should be 1. So n prime x. Okay. So it becomes that we have replaced this 1 with x. And then we apply this binomial expansion formula to here. Then this one has n minus k power, and this one has k n minus k choice. And multiplicity is just the binomial coefficient. What happens if I have a very large n that goes to infinity? We know n factorial divided by n minus k factorial. That cancels this part in the n factorial. So the hidden factor k, n minus k, n minus k minus 1, and so on until the end, they cancel this denominator. So we end up with this, and let's see, this n minus 1 to n minus k plus 1, they are k factors. And if I divide this one with the n to the kth power, it becomes each factor of n is distributed in every factor to find that everything is 1 times 1 times 1 times 1. So this value is exactly 1. As a result, this expansion is clearly simplified into this form. This power series expansion was found by Euler. That's the reason why Euler constant. And later, it was established. The Taylor series expansion was established. When you learn mathematics, the calculus class, perhaps in the second semester you will learn about that. But well before that, we already know how to compute this in a very simple way as a physicist to do. So these are some application to negative values, and result is given in here. And we frequently make use of this power series expansion. This is a conversion to this exponential function arbitrarily closely. So it is a very, very important in this semester and forever. Another thing you have to learn is if you consider the motion of an object that is attached to a spring, it is called the harmonic oscillator. The solution of a harmonic oscillator is a sinusoidal function. Okay, so let's think about the sinusoidal function a little bit based on the result obtained by Euler. And Euler is the person who found this is equivalent to this. This is the reason why it is called Euler's formula. Okay, so let's see. We just have seen exponential is exactly the same as the power series. It is not a geometric series because we have a k factorial in the denominator. However, it is absolute convergent, so why don't we substitute I in here as a factor? Before that, we can make use of the chain rule to find that. I hope you know what the derivative of the exponential function. It is exponential function's derivative and integral are both exponential. And if I have a factor of a as an argument, we can make a chain rule to change a variable, for example. This replace this one with the ax, and because I divide this expression by a, I have to cancel it by multiplied by a. And then this ax, they are identical. Therefore, if it is true, I can substitute ax for the original x. Therefore, it is true. So the final answer is I have additional factor a multiplied by the exponential function. That's true even if I substitute I for this a. Therefore, my final result is like that. However, I already know very simple power series expansion of the exponential function, so I substitute in here, and what I have done is replace this x sub k with ix sub k. So, however, because I is a square root of -1, if I make use of it, I squared equals -1, and if I repeat that calculation, I know how to evaluate the nth power, this geometric series. If I substitute this result in here, that one becomes a very strange series. This one contains even powers only, and this one contains odd powers only, and there is an oscillating factor coming from the I squared equals -1. And actually, if you solve this, you will find there's a special nature. There is a flipping nature of the cosine and sine. Cosine's derivative is minus sine, and sine's derivative is cosine. This nature is satisfied. Finally, if you compare the two series, you will find that exponential ix is cosine x plus I sine x. This one appears so frequently in the rest of this semester or in the next semester, you have to keep in mind